artificial intelligent drone scripts and algorithms are shown in this application, and the flight test is also illustrated in this video. Here is the drone software design methodology as implemented with the following scripts. The Python software script to fly the drone. First, make the directory in DK, then cd to DK directory. Afterwards, import all dependencies such as connect vehicle mode, import time, import socket, import exceptions, input argument parse or argparse. Afterwards, connect my copter drone. This script connects to the Python script to the drone firmware. So this is where the actual firmware takes place. Here I need the IP address to the drone. The RX connect is the IP address to manipulate the drone. So you need to set up several functions as well. The next function is called arm and takeoff function. As a result, arm and takeoff function enables the drone to take altitude and also to set up flight mode for guided flight control mode. After all these steps have taken place, confirm the drone is armed for flight. All of these scripts are shown and illustrated in this application, in this project, in this video as well. Now you're ready to place a while block function to the program to put the flight loop within 95% of altitude. And here you need to call the functions on the copter mission. Once you have done all of this, the drone will adjust its flight height to 2 meters. Takeoff and land, that pi is a function, and then tie the strings for flight mission, for automatic mission, followed by turning on the RC controller script. Then set and type the IP address connect script, which is Python takeoff and land.py. Now you're ready to take a flight test as illustrated in the video in this application. The artificial intelligence, cognitive drone, mission plan, and state machine. Fundamentally, there are 2 state machines running in parallel. That is the system architecture embedded in its firmware, which is the internal drone state for guided, takeoff, auto, and manual. And also the software scripts written in Python that represent the drone mission state machine. So let's define the mission and determine the number of waypoints by adding waypoints to the current mission define the change mode by adding latitude, longitude, and altitude to the current mission, as I have illustrated in all the scripts presented in this video applied in this specific application. So let's continue with the mission methodology. So now define the state machine by setting the ground mission when the drone is at 10 meters in height. Then define the takeoff mode and set up the change mode. Now let's start the script and download the mission and set up all the waypoints as indicated in the software algorithms presented in this material. So let's set up the ground mode, takeoff mode, and set flight mode, and also set autopilot mode, and then set up the return mode. That would be the sequence of the design methodology, and make up the mission state machine. These are the scripts, the mathematical software algorithms and scripts used in this specific application for the artificial intelligence cognitive drone. So, software scripts to calculate gyroscope angles is part of the design methodology for the drone. Calculate the travel pitch angle and the angle pitch variable. Soon after, set the sine function in degrees, and then set the IMU, yaw, transfer the roll angle, and then transfer the pitch angle. Then calculate the accelerometer vectors. Here, calculate the pitch correction and calculate the roll correction. Set the drone motors. Set the PID controllers. Now it's time for us to set the gyro calibration by setting the throttle to all different positions. Set yaw, pitch, and roll, and followed by setting the ESD and setting the motor control, and of course balance the prop and motors and ESD. Finally, set motors for all clockwise and counterclockwise movement, and calibrate all motors.